Good morning, everybody. We are going to move on from area to surface area today. Um, Related idea, but we're getting into kind of three-dimensional shapes instead of two-dimensional shapes. So instead of talking about circles or squares or rectangles, triangles, trapezoids, we're going to talk about prisms. And now the good news about prisms is just like with composite area the other day, prisms are made up of other shapes that we already know how to find the area of. So it's going to be real similar to the approach we took with composite areas. Okay. So our son's question, make sure we have it down, is how to find the surface area of prisms. Okay, so we're going to start with a formula. This is the official formula for the surface area of a prism. It's not one, it's one you should have down, and we're going to come back and we're going to look at it and try to figure out or try to understand where this comes from. But our idea today is not just going to be like plugging into this formula. We're going to be looking at kind of the idea of adding up some different areas to get a surface area. But we should have this down so we can understand where it comes from, and this will also help when we um, get to our cylinders tomorrow. So, the surface area of a prism is the perimeter times the height plus 2 times the area of the base. Okay, so pH plus 2b, where the big B here is the area of the base. So that's not just like a base, like in a triangle, but it's the area of the shape that's a base. Could be a circle, square, triangle, whatever. H is the height of the prism, and P is the perimeter. Remember, perimeter is the area around the outside. Okay, specifically this perimeter of the base. All right, so surface area. Surface area is the total area of the surface of a three-dimensional object. That's what surface area is. Okay, perimeter is the distance around a two-dimensional shape. So surface area is kind of like the 3D version of perimeter. Okay, but surface area is the total area of the surface of a three-dimensional object. So you can think about it as being like if you're going to wrap a present, how much wrapping paper you would need. It's the area of the surface. Okay. When we're talking about prisms, we're going to use the terms face and base. So you should know what that means. So face are the sides of a three-dimensional shape, so around the outside the sides. The base is the bottom and top of a three-dimensional shape. Okay, so prisms are named after their base. Now, we're going to say bottom and top, but we're going to talk a little bit more about what that means. But keep in mind, the surface area isn't going to change if you take a prism and put it on its side. So these might be arranged differently. So the bases might not be at the bottom and the top, but the bases are going to be congruent shapes. Remember, congruent means the same, that are parallel to each other. So we'll take a look at what that means when we start looking at some prisms. The lateral surface area. If you ever hear the word lateral, lateral means side. You might think of other areas you've heard the word lateral. Okay, it always means side. So the lateral surface area is the surface area of the sides, or just the faces. Okay, so lateral surface area just doesn't include the bases. All right, so make sure you have those definitions down. We'll start to look at some examples. All right, so I told you that prisms were named after their bases. Okay, so this is an example of a triangular prism, or the net for a triangular prism. So what I did is I took a triangular prism and I unfolded it. Okay. If we go back here, you can see what it would look like unfolded. If you think about kind of breaking this down into the sides, it's got a triangle at each end, and then it has three rectangles around the outside. So if you think about unfolding that into a net, you would get something that looks like this. All right. So if we want to find the area, the surface area, the area of the whole surface, what we can do is we can just find the area of all of their sides and add them together. And that's going to be the approach that I'm going to call a net approach. Okay. If you think about a square prism, which is a prism that has a square for the bases, okay, that would unfold into even probably easier net where you just have 6 rectangles. Okay. Same thing for a rectangular prism. Okay. So square and rectangular prisms, you're just going to be finding the area of 6 different rectangles, adding them together. With a triangular prism, it's going to be three rectangles and then two triangles. If we look back at a picture of a rectangular prism, hopefully you can picture unfolding it. And you have the top, bottom, back, front, left, and right. So 6 sides, all of them are going to be rectangles. Okay. All right, so let's calculate some formula, some surface area. So I'm going to skip the formula for now, but we'll take a look at a little bit at why that formula would work. Okay, so if I'm going to use the net, that means I'm going to unfold this. And look at the measurements of each one of the 6 sides. So the front is 10 by 6. Okay. The back is also going to be 10 by 6. Oh, that's front up there twice, but this should be back. Top and bottom are going to be the same. Side and side are going to be the same. Okay, so this should actually say top and bottom, but that's fine. All right, so we think about the front. The front is 10 by 6. The area of a 10 by 6 rectangle is 60. And we just multiply those dimensions. Okay, so the front is 60. The back is also going to be 60. Hopefully you can see the back will also be 10 by 6. So with rectangular and square prisms, it's even easier because you always get groups of sides that are the same, right? The top is going to be the same as the bottom. Front's going to be the same as the back. Side's going to be the same as the other side. So really, you're just finding, when you find one, you'll know the other. So really, there's only 3 areas that you're going to have to find. That's not going to be true with triangles. You got to be careful, but it is true with rectangular and square prisms. If I think about the bottom is 10 by 5, and so is the top. So 10 times 5 is 50. So the top is 50, the bottom is also 50. Okay. The sides are 6 by 5. So those are each 30. Okay. Same on both sides. So if I add those together, 50 plus 50 plus 60 plus 60 plus 30 plus 30. Well, 50 plus 50 is 100. 60 plus 60 is 120. 30 plus 30 is 60. If I add all those together, I get 280. Okay. So the surface area, or the area of the entire surface of this shape, is 280 meters squared. Okay. Now, if you think about this formula, the formula is saying do the perimeter times height. So we think about the perimeter of the base. That'd be all the way around. So this, and this. Multiply that by the height. Okay. But if you think about kind of cutting the box along this corner and unfolding it to get one big rectangle, you might see that the perimeter of the base times the height will give you the area of like all 4 of those sides put together. So the perimeter times the height gives the area all the way around, the lateral surface area all the way around. Okay. So that's what that would give you. And then 2 times the base, well, we find the area of the base, and then we double it because the top and bottom are the same. Okay. So this perimeter times height gives you the entire lateral surface area all the way around. And you just add the 2 times the base for the top and the bottom. Okay. So that's where that formula comes from. That's helpful. Use it. Otherwise, the idea we're using is just breaking it apart into easy shapes so we can find the area of. Okay. Let's look at another one. So if I wanted to use the formula in this case, I want to find the perimeter of the base. Now here's a good example of one that's not sitting on the base. Okay, this is a triangular prism. We got a triangle in front, a triangle in back that you can't see because it's on the back. But the bottom that it's in on is not the base, right? The bases of prisms have to be identical figures that are parallel to each other. So we got a triangle in front, triangle in back. Those are the bases. Okay. All the sides just got to go from one to the other. So the base is this triangle. If I wanted to use this formula and find the perimeter of the triangle, which is all the way around, so 8 plus 9 plus 10. So 8 plus 9 plus 10, if I add those together, I get 27. And multiply that by the height. The height would be the distance between the bases, which here would be 5. Okay, so I would do 27 times 5. Then I'd add twice the area of the base. Okay, so for the base, remember I would do, for this triangle, base times height divided by 2. So 8 times 9 is 72, divided by 2 is 36. So I would do 2 times 36 and see what I get. Okay. 27 times 5 is 135. 2 times 36 is 72. If I add those together, I would get 207. Okay, and that's just finding the area all the way around the sides first, and then the front and back. Okay. Let's take a look at how that works with the net. So if I unfold this into a net, we got this this rectangle here, which is 8 by 5, right here. I multiply and get 40 for the area there. Okay. This one here is 10 by 5, which is rectangle 2. 10 times 5 is 50. Okay, rectangle 3 is on the back. Here it's 9 by 5. Okay, so 9 by 5 is 45. Okay, for the triangles, again, it's base times height divided by 2. So I already did that part. So 8 times 9 is 72, divided by 2 is 36. So this is 36, and the back one is also 36. Okay, so we got all those together. We get 100, this is 90, 135 plus 72 is 207. We get the same answer, 207 centimeters squared. Okay. All right. Why don't you try this one? Okay, so I'll give you a minute to figure out on your own the surface area of this shape. When you got it, hit resume and see if you're right. All right, welcome back. Hopefully you got 280 meters squared for this surface area. Okay, we got the sides are 6 by 5, so they reach 30. Okay, the top is 10 by 5, so the top and bottom are both 50. Okay, front is 10 by 6, so front and back are both 60. If you add all those together, you get 280 meters squared. You do not seem to have an example of, oh, we do. Okay. All right. All right, let's try one more. So this one I did not provide the net for you. You're gonna have to figure out what the net would be yourself. This chest is 16 inches high, 24 wide, 15 deep. Okay, if Molly paints only the outside of the toy chest, so that's the surface area, what is the total surface area in square inches she will paint? So again, pause it, see what you can come up with, and then check to see if you're right. Okay, welcome back. Hopefully the answer that you got is 1,968 inches squared. So the front and back are 16 by 24, so 16 times 24, and then I multiplied by 2 to get the front and back is 768. Okay, the sides are 15 by 16, and again, the left and right are going to be the same. So 16 times 15, and then I doubled it, is 480. And lastly, the top and bottom are 24 by 15. So 24 times 15, double that, is 720. Okay, add all these up, and you get 1,968. Okay, what if Molly did not want to paint the bottom? How many square inches will she paint? Okay, so if she doesn't want any paint on the bottom, what would I do? Well, fortunately, I already figured out the area of each one of the sides. I know the area of the bottom would be 24 times 15, okay, which is 360. So just like I did with composite area, if I want to leave off the bottom, I would just subtract 360 from the total. Okay. So 1968 minus 360 would give me 1608 inches squared. Okay, so that's a pretty easy question when you use the net. You can just subtract one of those pictures. Again, I only subtracted 360, not 720, because 720 is the top and the bottom, right? Because I doubled it. So 24 times 15 without being doubled is 360, which is the bottom. All right, good luck. Let me know if you have any questions.